this video, we're going to discuss how to write names and formulas for compounds with polyatomic ions. So, what is a polyatomic ion? A polyatomic ion, quite simply, is a group of atoms that act together like a single ion. So polyatomic ions, to understand what it means, it helps to break the word down. So poly just means many. So literally, poly means many atoms. And ions are charged atoms that gain or lose electrons to become charged. Most polyatomic ions are negative and behave as nonmetals in a compound. An exception to this is ammonium, which acts as a metal. So here's a list of common polyatomic ions. It helps to learn to recognize these, but in a test situation you would be given these. So don't panic too much. What I want you to look at and learn from it is have a look at the endings of these polyatomics so you can learn to recognize them. So first thing you'll notice, if I look at chromate, for example, which is over on the right hand side with a -2 charge, chromate, like many polyatomics, ends in ATE. And the ATE ending is a surefire way to recognize a polyatomic. The other thing we can look for is an ITE ending, such as sulfite. Okay, so if we see those endings, we can be sure that we're looking at a polyatomic. A couple of exceptions to this, and ones to recognize and perhaps even memorize, are the hydroxide ion, down near the bottom here, and the cyanide ion as well. Less important, but understand that most nonmetal ions end in IDE, but so do cyanide and hydroxide. The ammonium ion, right here at the top, is the lone example that you'll recognize in your examples that deal with it, that is basically acting like a metal, so they'll lose electrons in a chemical bond. Let's look at some examples here on how to write formulas. So writing formulas for ionic compounds with polyatomics is very similar to that with binary ionics. So the first step is look at the periodic table, see if you can identify the ions. Now, in this situation, what you'll recognize, or what you'll want to notice, is that, again, we want to use the common ion chart. So use the tools you have available. So use the common ion chart to identify the polyatomic ions in the compound. Again, if you look at the periodic table and you don't recognize the ion name in there, then the odds are you have a polyatomic. So, second step is to write the ion symbols and their charge. Third step is to add more of each ion until the charge is balanced. Again, in an ionic compound, we want the charges to add to 0. And then you write the formula using brackets where appropriate. So you don't use brackets in binary ionic compounds, but you do with polyatomic. So let's take a look at some examples and we'll see what that looks like. The first example is magnesium nitrate. So magnesium is a group 2 metal, an alkaline earth metal, so it has a positive charge. And nitrate, from the polyatomic ion chart, you'll notice has a charge of -1. So if we look at these, we'll notice that the charges aren't balanced. So I'm going to need another nitrate ion. So I'll write it down, and then I can just simply count to determine my chemical formula. So I have 1 magnesium, 2 nitrates. My formula is MgNO32. So I need to use the brackets. And this tells me that I have 1 magnesium atom, 2 nitrogen atoms, and 6 oxygen atoms, for a total of 9 atoms in the compound. And this will become important. Another example is calcium sulfate. So calcium is group 2 like magnesium, so it has a charge of 2+. Sulfate has a charge of -2. So those charges are already balanced, so I can just write out my formula as CaSO4. Notice no brackets. So don't use brackets unless it's absolutely necessary. It's only necessary when you have more than 1 polyatomic ion in the compound. Look at the last and most complicated example. So here we have ammonium phosphate. So ammonium is the one you need to recognize. It's a polyatomic ion with a positive charge, so it has a charge of +1. Phosphate has a charge of -3. You can look and see that these don't balance. So we need to add 2 more ammonium ions to get a total positive charge of +3. and therefore my ammonium ion and ions and my phosphate ion add up to 0, so I can now write the formula, which is NH4, 3, in brackets around the ammonium ion, PO4. The question I can throw out is, how many atoms do I have? So to determine that, what I do is I look inside the bracket, so I have 5 atoms inside the bracket, and I have 3 outside the bracket. So 3 times 5 gives me 15 atoms from the ammonium ion, plus 5 atoms from the phosphate ion. So I have a total of 20 total. Now, naming compounds is actually a little less complicated. So the steps are to check the formula for polyatomic ions. Again, if I have more than 2 capital letters, essentially that tells me I have a polyatomic ion in there. Now, when naming, there's no name change for metals, and non-metal elements end in IDE. And there's no name change for polyatomic ions. So in other words, if there's a polyatomic ion in the compound, I just name it as it is on your chart. So let's look at some examples. First example, NaOH. So I want to identify the ions. First step, again, identify the ions. I have the sodium ion, and I have the hydroxide ion. And because I don't change my name in polyatomics ion and polyatomics or the metal, I just write it out. So NaOH is sodium hydroxide. Look at another example. So K3PO4. Compound contains a potassium ion and the phosphate ion. So naming it just becomes potassium phosphate. And last, here I have NH4,2S. So I'll be able to recognize using the common ion chart, ammonium and sulfide. As sulfur, I can look at periodic table. So the compound contains the ammonium ion, NH4 plus, and sulfur is a non-metal. It becomes a sulfide ion. So my rules are to change the sulfur to an IDE, so the sulfur becomes a sulfide ion, and this becomes ammonium sulfide. So that's a brief lesson on how to name and write formulas for polyatomic ions. I hope it's useful. And again, just keep practicing.